All right, well, thank you all for joining this session on Gloo Mesh, and we're going to take a look at what Gloo Mesh is, what it does, and where we're going with it, and some of the new things that you can do with it. My name is Posta. I'm the field CTO here at Solo. I've been involved in the service mesh ecosystem for quite a while now and helping companies and organizations adopt service mesh technology. And with me, co-presenting, we have Joe Kelly.
Hey, I'm Joe Kelly, the engineering lead on Gloo Mesh at Solo.
Awesome. So we've been digging into service mesh and participating in the ecosystem here for the last 3 years or so. And one thing that we noticed from the very beginning is that there wasn't going to be just one service mesh. And from the beginning, we noticed, as you can see, some of the different logos here on the slide, that there were going to be different cloud provider service meshes, like we're seeing from Open Service Mesh from Azure or App Mesh from AWS. We're going to see, so Istio and Linkerd were some of the first couple that started off, and then other folks have now jumped in. And what we've noticed is that it's difficult for folks to figure out which one to use, which one best fits their organization, where they're going to get support. Is the API the right API for them? Can you introduce it transparently? Does it support VMs and non-container-based workloads, multiple clusters, and so forth? And when we initially started attacking these problems, we open sourced a project called Superglue that focused on simplifying some of the complexity around adopting and installing and managing a service mesh. And we started off by saying any service mesh. All right, so we came up with this idea of an abstraction to simplify how you actually interact with a service mesh, regardless of what mesh you may choose. Now, we use this abstraction to focus on what are some of the core features of a mesh, maybe those that might be common across other meshes. And this picked up some interest from the rest of the community and started the movement around the service mesh interface. Now, fast forward a little bit. This was back in, I think, May 2019. But fast forward a little bit, and one thing that we've noticed, or has at least become clear to us, is that while there are a lot of service meshes, and each one has their own API and own intricacies to it, a winner is emerging. And it's a lot easier to focus an abstraction or an approach to try to simplify a mesh when you have one API versus, let's say 10. And what we've noticed is that Istio is emerging pretty convincingly as the winner in the sort of self-managed service mesh space. And so we saw all of our customers adopting, going to production with Istio, and we said, all right, Istio still is, its API was written in such a way that it enabled automation on top of it, and wasn't really designed for end users as developers and so on to use that API. So we decided to continue our efforts to simplify service mesh adoption and management and day 2 operations and focus on Istio. And when you take an Istio service mesh and deploy it into your environment and operationalize it, there are these issues that you run into, especially across multiple clusters. When you deploy for high availability and isolation and fault tolerance and so on, making these clusters aware of each other, federating their identity, sharing enough information to enable service discovery, establishing consistent security and access policies, defining failover and these types of configurations. These are, that adds a level of burden to the operator that to make it successful that we would like to simplify and focus on. What is it that the end user is trying to do? And so we fast forward Superglue rather into Gloo Mesh, and that's exactly what we've built, is a product that allows you to run Istio in production with enterprise support and SLAs and so on, and manage that across multiple clusters. And we'll go into a little bit more detail about what some of those features are. So Gloo Mesh Enterprise is a supported upstream distribution of Istio, and I'll go into a little bit more detail on that in a second, that can be run across multiple clusters, potentially clusters with multiple different versions of Istio, run on-prem or in any cloud or both, in a hybrid scenario. And so what we've done with Gloo Mesh is we've simplified the operations of running Istio in an environment like this, which then enables things like failover and global failover routing, locality-based routing, the tooling we've built under the covers to help you unify observability and get you a single pane of glass for watching the telemetry and the tracing and so on that's happening across multiple clusters, giving you a unified API for configuring traffic policies and access policies, as well as extending the mesh, extending the underlying data plane, which is Envoy in Istio's case, with WebAssembly. And our original idea of supporting multiple meshes is still holding true. We have users that are interested in running Istio and app mesh together and federating those. So supporting multiple meshes is still part of the charter of Gloo Mesh. So let's start with the Istio piece. So we have builds of Istio, they're upstream based Istio that we build and we're able to support in a production environment. And by support, I mean, if things go wrong, things break, we'll fix it. Istio's community supports their versions for N-1, so it really isn't a long-term support option in the community. And this can be very important for those organizations that care about security, vulnerabilities, and so on. They don't get patched in the community after N-1. We support LTS for long-term support for N-3. We offer enterprise SLAs for, we'll pick up the phone call at 2 o'clock in the morning. If something's going down, we'll jump in there and we'll help you fix it. We'll patch it, deliver to you that fix. And before you even get there, we'll offer architectural guidance and best practices. And, we've built up a very strong, we're leaders in the Istio community, and we've built up a very strong practice around getting people successfully running Istio in production. Now, then you fast forward to, okay, we got Istio running. Now we got multiple groups running Istio, hosting multiple services. We want services to be highly available and they might communicate across clusters. And now, if you're familiar with Istio and Istio's API, creating virtual services, destination rules, sidecars, all those things, doing that across multiple clusters can be very, tricky and error prone. Even if you got all the automation that you've built, all the GitOps flows and all that stuff, tracking which virtual service goes onto which cluster, and if a particular service moves, there's inherent directionality in the traffic flows and the access policies here. Managing all of this stuff and trying to orchestrate it yourself becomes very cumbersome and error prone. And you might know that configuration is one of the leading reasons why large systems like this might go down. So that's where the Gloo Mesh management plane comes into the picture. So the Gloo Mesh management plane allows you to centralize your policy writing and definitions and so on, and orchestrate them and automate those out to the individual Istio clusters. Now, Gloo Mesh comes with a simplified API. So again, this stays true from the very beginning, where we were focused on simplifying the adoption of a service mesh. We offer a simplified API for defining traffic policies, which is multi-cluster aware, for defining access policies, for restricting traffic to or from certain clusters, whether that's on-prem or in a public cloud. And you basically focus on what is supposed to happen with the traffic between services, and let the management plane automate where that config, it translates it under the covers to Istio config, where that configuration needs to go, on which clusters, when it needs to be updated, when it needs to be removed, and managing that whole orchestration problem. So let's take a look at real quick some of the features that are enabled by this API. The first is the virtual mesh API. Now the virtual mesh is an abstraction. So again, it's a custom resource. Let's come back to this diagram. When you look at this diagram, you see Istio running on a bunch of different clusters. The management plane runs on its own independent cluster somewhere else. Right, and it connects up to the various leaf clusters. And actually in the enterprise product, that connection happens over gRPC, and it happens in the reverse, right? The clusters actually connect up to the management plane and identify themselves as, hey, I'm cluster 1, give me my configs, and the same thing with cluster 2. So you don't end up with a scenario where one cluster has access to everything. Or, as you might notice in the Istio community, the documentation for setting up multiple clusters, each cluster has access to every other cluster. Also not a very good security posture. So with the Gloo Mesh management plane, you have the leaf clusters connecting up, identifying themselves, and then the management plane is able to push out configs. Now, defining what the configuration boundary is or what clusters should participate in this abstraction is what the virtual mesh custom resource or the virtual mesh abstraction does. It abstracts a group of individual isolated service meshes, each with their own Istio control plane, and treats them as though they were one single mesh, and orchestrates things under the covers like the config, like we talked about, as well as federating any of the identity and trust domain properties of each of the clusters so that services in one cluster can talk to the other. It does discovery of the various services that are running in each of the clusters. So it can build a global service discovery catalog. And it also automates and orchestrates some pieces inside of each of the clusters to facilitate telemetry collection, log aggregation, and some of these other things that we need to get a single pane of glass for observability across the different meshes. The next part of the API is a traffic policy. And the traffic policy is explicitly modeled in such a way that as a developer of a service or operator of the system, you focus on the connections between services. What is the source? What is the destination? And you write traffic policies, routing policies, fault injection policies, retry policies, timeouts, and so on against that link between a particular service or a particular group of services and another service or a group of services, right? So it's a from and a to, or a source and a destination. And what is the policy that applies to that link? We can see right here a little bit closer, right? We select our sources using selectors, regardless of what cluster they're on. The targets, same thing, regardless of what cluster they're on. Now it is multi-cluster aware, so you can specify cluster specifics, but you identify source, target, and then what is the policy that should be applied to that link. And then Gloo Mesh will go translate that to the correct Istio resources like virtual service, destination rule, and so on. Same thing with access policy, and this is really important because when you're defining rules about what services should communicate or should not communicate with each other. Maybe something on a public cloud should not be able to call back into the services in a private data center. You know, using the same declarative semantics with source and destination as we saw previously in the traffic policy, we have the same thing for the access policy. So we say for this source or this group of sources and this destination or this group of destinations, these can communicate with these characteristics or these cannot communicate. So similarly to the traffic policy, the access policy gets translated into the various appropriate Istio resources and then orchestrated onto their individual clusters. And then the individual control planes of those clusters will pick up these configs and configure their respective data planes in that case. And like I said, the individual control planes are separate and isolated. And if any one of them were to go down, the rest of the system performs fine. If the management plane goes down, these are still individual Istio control planes. They're able to run just fine. So it ends up being a very resilient system. And now let's take a look at this API when you start to use it across multiple different teams and different personas in your organization. We'll have Joe Kelly take it from here.
Thanks, Christian. Yeah, like you said, typically in an Istio deployment in the world of service mesh, you're going to have a lot of stakeholders. You're going to have the administrators of the global environment. You're going to have local administrators, service owners, individual developers, etc. And when you're dealing with just plain Istio configuration and all of the many interlinked API objects therein, you're going to have issues of contention as to who owns a given resource. When you need to use a virtual service, a destination rule, and a sidecar in order to achieve a certain routing behavior, it becomes unclear where the lines are between who owns what resource. With the Gloo Mesh API, we can leverage a persona-based API in order to make those lines more clear. As you saw, our traffic policy and access policy APIs make it explicit which services and workloads they'll be affecting within a cluster. Gloo Mesh then can offer an intermediate layer in the form of an RBAC webhook, which will restrict certain services or even individual routing features on the traffic policy to a given persona, which is defined by the user. For example, you can offer a book info service owner persona who has the ability to define access policies and traffic policies only within the book info namespace. Then a different administrator persona might be responsible for dictating which external services can access those services which are only exposed through book info. Another benefit that is provided via Gloo Mesh Enterprise is the ability to deploy WASM filters to Istio workloads across clusters. Here, we are again leveraging the selector API to distribute arbitrary functionality to sidecars within the mesh. Simply list a selector for the workloads which you would like to receive a given WASM image, and that WASM image will be pulled down by a cache local to each cluster and served to the sidecars running there. Not only that, Gloo Mesh also exposes a command line utility, meshctl wasm, which will help you through the entire development workflow for building these WASM filters in the language of your choice. You can then push them to a registry and make them available to Gloo Mesh to pull down and add features like header manipulation, body manipulation in your requests, as well as additional network hop-less authorization plugins, so that you don't need to configure an external auth server in order to add arbitrary auth functionality to your service mesh. Also bundled in Gloo Mesh Enterprise is the ability to provision global services through our virtual destination API. The virtual destination API offers a couple of modes. One is a serial failover scheme where users can specify an order of services which should receive traffic in the event of an outage or otherwise detected outliers, or a locality-based scheme for multi-cluster load balancing. Users can specify an arbitrary service name, which would then be propagated throughout the mesh using Istio's proxy DNS, and then specify a list of localities in priority order, which should receive the traffic. This way, users don't need to think about where a service is located in order to access it. Gloo Mesh also offers plenty of functionality around multi-cluster observability. Here, we see the workflow by which Gloo Mesh is able to aggregate metrics from across clusters and ship them back to the Gloo Mesh management plane. Here, you see that metrics are going from the sidecars on each workload on each cluster through an agent, which is running on those clusters, back to the management plane. This is leveraging the same secure architecture that Christian mentioned earlier in order to ensure that all of your metrics are encrypted when they make it back to the management plane. On that management plane, we can do interesting things with the metrics, such as provide this graphical view of what the service traffic within your environment, the health therein, all in the same place where you can observe the various policies that are at play within your mesh. This single pane of glass is available not only to users who are reliant on Gloo Mesh for metrics aggregation, but also to others who might have a more long-standing metrics aggregation system in place, such as federated Prometheus via Thanos. The Gloo Mesh metrics functionality is all pluggable so that you can aggregate your metrics however you would like and still benefit from the different observability features that we have today and will be adding over time. Gloo Mesh Enterprise goes a long way to making it easier to manage service mesh. Configuration is a lot simpler. All you have to think about is sources and destinations for various routing features, security features, and additional functionality that's brought to your mesh, rather than having to wrangle complex interlinked APIs. Gloo Mesh also offers long-term support for Istio, back to N-3, with bug fixes and security patches. We're also there to help you secure your assurance for your service mesh choices. We all appreciate Istio as a leader today, but the service mesh ecosystem is rich and ever growing. So by integrating with Gloo Mesh, you are not bound to any given mesh implementation. You'll also be granted access to the experts here at Solo. We have a rich team of Istio operators and community members who are here to help you succeed with service mesh. You'll also be on the leading edge of service mesh technology by getting on board with Istio at Solo. And we'll help you delineate between developers, operators, service mesh day-to-day users or service mesh observers via our role-based API and the other abstractions provided by Gloo Mesh. And we're there to support you regardless of the cloud provider that you use, and in addition to off Kubernetes deployments, such as virtual machines and function as a service. What's next, might you ask? Gloo Cloud. Gloo Cloud is managed Istio across any cloud. It's fully managed, it's first of its kind, Istio service mesh as a service. You'll be able to discover, connect, secure, observe, and federate your service traffic across clusters, data centers, clouds, anywhere your workloads might be running, all through a single pane of glass managed by the experts here at Solo. Let's take a look at Gloo Cloud in action. This is Gloo Cloud, the first and only Istio service mesh as a service, bringing all the benefits and power of the Istio service mesh to all of your clusters, data centers, and clouds through a single pane of glass managed by the experts here at Solo. Gloo Cloud is a fully managed solution for Istio. Let us handle installing, upgrading, and the rest of the Istio lifecycle so that you can focus on building your APIs and delivering value to your users. Gloo Cloud makes operations easy with unified dashboards for traffic management, security, and observability. Gloo Cloud offers a rich suite of security features, including identity, policy, MTLS, authn, authz, and audit tools, all on top of FIPS-compliant builds of both the Istio control plane and Envoy proxy data plane. Gloo Cloud enables global service load balancing, federated traffic, and access control, regardless of where your workloads are running. Gloo Cloud also supports complex rate limiting, usage plans, and billing use cases, no matter where your services reside. Sign up to get started. Once you're registered, we'll get started provisioning your environment with the Istio service mesh and the Gloo Mesh management plane. It'll take a few minutes to get that environment ready, so let's take a look at today's application cluster. Here you'll see that we're running book info and nothing else. There's no Istio D, and those book info pods are not injected with the Istio sidecar. Taking a look at the product page, you'll see the default load balancing rules in place as we round robin through different versions of the review service. In a few moments, we'll leverage Gloo Cloud's managed Istio control plane to affect this policy. With our Gloo Cloud instance all provisioned, we're met with a few new fields on the My Credentials page. Here, we see a one-line meshctl command for registering clusters to the Gloo Cloud control plane. We have a Gloo Cloud kubeconfig so that we can apply API objects to the Gloo Cloud management plane, as well as a certificate and cluster registration token to enable declarative registration of new clusters to the Gloo Cloud management plane. Back in the terminal, let's switch to the kube context provided on the My Credentials page. And from here, let's register our application cluster to Gloo Cloud. This process bootstraps connectivity between the Gloo Cloud cluster and the application cluster, enabling Istio to configure workloads on the app cluster and Gloo Mesh to handle I/O across clusters. Now let's switch back to the application cluster, label the book info namespace for sidecar injection, and bounce all of the book info pods in order to see injection take place. Here we see that the Gloo Mesh component of Gloo Cloud has discovered all of the destinations and workloads corresponding to each book info service. And when we fetch the pods in the book info namespace, we see that they have all been injected. Now let's switch back to that Gloo Cloud cluster. Our permissions on this cluster are limited to those that are needed to manage our services on remote clusters. And what that means we can do is apply a traffic policy to the Gloo Cloud cluster and then have it reflected on the registered application cluster. Here, we create a traffic policy called simple with a simple traffic shift policy. Here, we see that we want to divert 75% of traffic to the v3 review service, 15% to v1, and 10% to v2. Back on the application cluster, let's take a look at the virtual service that's been propagated to the cluster to apply our new routing policy. There we see the same 75, 15, 10 distribution as we specified on our traffic shift. On the product page, after many refreshes, we now see a lot more red reviews v3 than we do black stars or no stars. This indicates that our traffic shift has taken effect. Now let's take a look at the Gloo Cloud dashboard. Once you're logged in, you're met with an overall summary of all of the meshes, destinations, and workloads in your system. You can see their health status, the number that you have, and get a quick bird's eye view of how things are going across all of your clusters. Let's dig a little deeper, starting on the clusters page. Here, we see that we have one registered cluster, remote cluster, and on it, there's just the one service mesh, Gloo Cloud Istio. Istio as a service provided by Solo. Clicking in here, we can see all of the destinations, workloads, and configuration policies that are applied to the remote cluster managed by Gloo Cloud Istio. Let's take a look at that traffic policy we created earlier. Here we have a nice view of the status and affected workloads and destinations by this simple traffic policy. We can also click into the Debug tab to see all the nitty-gritty details of the Istio config that's backing our system. Here we see that same virtual service that configured the book info app that we observed earlier. This is just a hint of all of the observability and telemetry tools coming to Gloo Cloud and Gloo Mesh. Stay tuned to SoloCon and solo.io to learn more about the features coming to Gloo Cloud.
Well, thank you, Joe, for that demo on Gloo Cloud and the first and only Istio as a service for any cloud. And that concludes our talk. I want to thank you for joining. And I'd like to point you to some of the links where you can learn more about what we're doing here at Solo, including Gloo Cloud and some of the open source communities that we work in, and join our Slack to continue the conversation. So we appreciate you joining this session.